Okay, so in this video we're going to be reviewing a test on motion graphs and Suvat equations. So in terms of the skills that this test was having a look at, that's what you can see in this list here. We can see all the different things we're going to look at. So some of them we've got some definitions described, some applying equations, and then some explaining as well. So those are the general kind of skills we're looking at. So let's take a look at the first question. Okay, so we're going to start off with a few multiple choice questions. So we've got a girl jogging at 2 meters per second, so that's her speed, in a straight line for 30 seconds. She turns around and returns to her starting point 20 seconds later. What is her average velocity and average speed? So the first thing I picked up on is that the time for the journeys is different. So we know the speed must be changing from the first one to the second one. It must be running faster on the way back. So the next thing I picked up on is she returns back to her starting position. So at the end of the time, her displacement is actually 0. So if her displacement is 0, her average velocity is going to be 0 because the average velocity is change in displacement divided by time. So if your displacement is 0, then your change in displacement is 0, that means average velocity is 0. So we know it's either A or B. Next, we have to figure out how far she has travelled. So we know on the way out, she ran at 2 meters per second for 30 seconds. So she ran a total of 60 meters out, which means her total distance travelled must be 120 meters. So once we've worked out the distance, if we divide that by the time, we'll get what the average speed was, 2.4 meters per second. Okay, so then if we have a look at question 2, we want the relationship between distance travelled and the time an object has been falling. So the key thing to pick up is it's falling from rest. So if we pick our general Suvat equation, this one, the relationship between displacement and time, if it's falling from rest, that means u is 0, so we can write it like this, where the acceleration is going to be g, or the free fall. So we can see in here, half and g are constant, so s is directly proportional to t squared. So that's option A there. Moving on to the first of the getting longer answer questions, question 3. The first thing I want to do is define what acceleration is. So this is something you just have to know. So acceleration is the rate of change of velocity. No other answer is acceptable there. That's what acceleration is. So then state why acceleration is a vector quantity. Well, acceleration has both magnitude and direction. Having those two things makes you a vector quantity. So the next one, state what feature of a velocity time graph may be used to calculate acceleration. Features of a graph tend to be gradients or areas under that kind of thing. So acceleration is the gradient of a velocity time graph, and displacement is the area between the graph and the x-axis, or commonly referred to as the area under the graph there. So that's our features. Okay. So the next part, we've got a graph of displacement against time for a runner along a straight track. And it wants us to sketch what the velocity time graph looks like for that. So the first one is identifying, you can see the gradient is decreasing to 0 at the starting point, which means our velocity is going to start at 0. Then what happens is the gradient increases, so we know the velocity increases. Then the graph becomes a straight line, so the gradient becomes constant. So we've got for constant velocity there. And then we've got the gradient decreasing to 0, so velocity decreases to 0. So what I've said over on the left is the sections 1 and 3 could be curved. So in terms of how you draw on those, it doesn't matter too much. I went for a straight line, but the key things you need, it starts at 0, you've got the straight section here, and it ends at 0. We've got those two connections in between. Okay, so that's part C, and that finishes question 3. Let's move on to question 4. Okay, so this first part again is just testing your knowledge. So the two vector quantities here, we have a velocity and displacement. They have both magnitude and direction. Speed and distance just have magnitude. They don't have a direction, so those are scalars. So the next one, we've got a tennis ball thrown vertically downwards and it bounces on the ground, the ball leaves the hand with an initial speed of 1.5 meters per second. So that's why we've got u is equal to minus 1.5, because it's downward and at 1.5 meters per second. It starts at a height of 0.65 meters to the ground, so when it hits the ground, it's going to go downwards by 0.65 meters. The ball rebounds and is caught when travelling upwards with a speed of 1 meters per second. So it wants us to show that the speed of the ball is about 4 meters per second just before it strikes the ground. So just when it reaches the ground, it's going to have gone down by 0.65 meters. It started travelling downwards at 1.5 meters per second. We want to know what its final velocity is, but we do not know how long it takes. But we know the acceleration is the acceleration due to gravity, which is 9.81 downwards. So if we don't have time, this is the equation that we use, and we'll rearrange that to then calculate what v is. So we've got the square root of u squared plus 2as. Now we do that, it comes out as minus 3.9, which is around 4 meters per second. This next question caused quite a lot of problems when I was marking it and people having a go. So the first thing is to remember our answer here was minus 3.9 meters per second. So just before it hits the ground, we can see it reaches minus 3.9 meters per second. So our section is going to have a line joining where it starts and minus 3.9. We also know the gradient is going to be constant because the gradient is the acceleration due to gravity. So the gradient should be 9.8, well, minus 9.81 there. Okay, so then once it's bounced and is going upwards, again, we know its acceleration is the acceleration due to gravity. So again, we know the gradient is minus 9.81. So we should see this line parallel to this line here. So these two lines should be parallel to each other. And the way I was testing whether it was or not is it should start around 3 meters per second there. So that's what the graph should look like if you've done it correctly. Okay, so then we've got, in a game of tennis, the ball is hit horizontally at a height of 1.2 meters from the ground, and it travels into 5 meters before reaching the ground. So let's sketch what this looks like. So the ball is up here somewhere, the ground is down here, and what it's saying is the height here is 1.2, and it says it's going to reach a distance of 5 meters. So essentially the path it's going to take will be something like this here. That's what's going to happen. So we want to calculate the initial horizontal velocity given to the ball. So if it was hit horizontally, what that means is that the initial velocity in the vertical direction is 0. Because if it's traveling horizontally, its velocity in the vertical direction is 0. So that's what we've got there. We don't know what it ends up at when it hits the ground. We know in the vertical direction it's going to go down minus 1.2 meters. We know its acceleration in the vertical direction is minus 9.81. So what we can do is we can find how long it will take to hit the ground. Once we've got that, what we can do is look in the horizontal direction. So we know it's going to go 5 meters to the right, so it's plus 1 plus 5. We want to know what u is. We don't know what v is. We know that there's no forces acting horizontally, so a is going to be 0, and we want to know what time is. So again, we're going to use this equation, a equals 0, so it becomes this one, rearrange, and we get a speed of about 10 meters per second. Okay, so next, a student measures the acceleration due to gravity using this apparatus. We're dropping a card from rest, so it starts at 0, and it starts from a height of half a meter there. The computer allows us to measure what the speed is when it reaches the light gate right here. So let's have a look. So we know it's going to go down half a meter. It starts from rest. The computer has determined final velocity is minus 3.1 because it's 3.1 downwards. We want to calculate what a is, and we don't know what t is. So if we don't know t, we're going to use this equation right here. We rearrange it with u equals 0, and that gives us an answer of 9.6 meters per second squared, which is fairly close to 9.81. So we know that's a pretty good value. So the next question wants us to explain why the card is better than a table tennis ball. So the force of air resistance on a card will be smaller because it's got a much smaller area that's falling through the air. So we're going to get an acceleration closer to the 9.81 value, which is what we're looking for there. So it's to do with air resistance, and it's to do with the fact that the area of it falling through is much smaller. And then next one, we've got a supertanker, which is like a giant ship, and it has a mass 4 times 10 to the 8, so we know it's pretty massive. And it starts at 4.5 meters per second, and it comes to rest in an hour. We want to calculate the force. Sorry, we're going to assume the force is constant, which means the acceleration is constant. So acceleration is the change in velocity divided by the time taken, if acceleration is constant. So that's what we've got there. And the time in seconds gives us this value right here. And it should be minus because it is slowing down. We want to work out the distance traveled. So I've picked this equation here. So we know U, we know V, we know how long, so it gives us 8.1 kilometers, or 8.1 times 10 to the 3, but there are other methods that you can use that would work and give you the same answer. This next question, sketch the distance time graph representing the motion. So the key is to remember that velocity is decreasing, so we know the gradient of the graph should be decreasing, which is what we can see here. But we know the velocity is always in the directions is positive, so that's why we know it's always going upwards, but eventually distance will stop changing because it has stopped. So to help, I sketched what the velocity versus time graph would look like here before doing this one. So this is the velocity graph, but then we would see what happens to the distance graph. So this section is basically explaining what I was just looking at. So velocity is the gradient of the graph. Velocity is positive and decreasing, so gradient is positive and decreasing. That's how we'd explain the shape. All right, so let's move on to the next question. So we've got the motion of 2 cars. We've got car A, which is this line here, and we've got car B, which is this line here. So it wants us to describe the motion of each car on the graph. So we can see here, car A is going at 16 meters per second the whole time, so it's traveling at constant speed. Car B has increasing speed, and it's a straight line, so we know it's constant acceleration for 5 seconds. Then it's traveling at constant speed of 18 meters per second. Wants to work out the distance traveled during the first 5 seconds. So you can see I've drawn a line up at 5 seconds, so we can see where we apply it to. So car A, the area under the graph is nice and easy. It's just this rectangle. It will be 5 times by 16, which is 80. Car B, the shape of the graph is a trapezium. So this is how you calculate the area of a trapezium. We've got the 2 sides of the trapezium divided by 2, and then times by the base, again 80 meters. So they've traveled the same distance at 5 seconds. So at time t equals 0, the cars are level. Explain why car A is at a maximum distance ahead of B at t equals 2.5. So initially car A is traveling faster than B, so it increases the gap between the cars. At 2.5 seconds, they are now at the same speed, and B travels faster than A after 2.5 seconds. So after 2.5, B is going to be closing the gap because it's now faster than A. So that's why the maximum gap is at t equals 2.5. That's where they are at the same speed there. Okay, so that finishes this video looking at this test. If you have any questions, please feel free to comment. I will try and answer those for you. But thank you for taking the time to watch.